In this video, we'll cover the formation of amides and acid chlorides. So these are two carboxylic acid derivatives, amides and acid chlorides. We've talked about esters. Esters are also a carboxylic acid derivative. We won't go through mechanisms in this video or for these reactions, but these are reactions where I'd like you to recognize the reagents, a combination of molecules, and predict the product. Or vice versa, given the product, predict the reagents. So we'll start with amides. And there are multiple ways to prepare amides, but we'll just show one here. So if you add a primary or secondary amine, or NH3 to an ester, that will generate, in the presence of heat, that will generate an amide. So let's look at general scheme. If we start with an ester, so a carboxylic acid derivative, ester functional group, the one oxygen is bonded to another carbon chain. If we add in a primary or secondary amine, let's write out the structure here. So we've got nitrogen bonded to at least one hydrogen, and then two other R groups. One or both of those could be a hydrogen. That would be NH3. They could both be carbon chains. One of them could be a carbon chain. So this is a primary or secondary amine, or NH3. This is a reversible reaction. It's in equilibrium. If we add heat, that will promote the forward reaction. And we produce an amide. And an amide has a carbonyl. Now that carbonyl carbon is bonded to the nitrogen, and then the two R groups that were bonded to that nitrogen. So this is an amide. And then our byproduct is an alcohol. The alcohol carbon chain, we'll label that as R prime, came from the ester, so that R group on the ester, and the oxygen from the ester. So this is one method to produce an amide, and you might remember from your other biology classes that many amino acids are linked through amide bonds. So now we see that functional group amide there. If you see an amino acid, you will likely see an amide bond in that amino acid. Okay, so there's one way to produce an amide. Now we'll move to acid chlorides. So remember, we're not covering mechanisms for these. But we'll talk about two reagents that will produce an acid chloride from a carboxylic acid. Here's an example of a carboxylic acid. We have 4 carbons in the chain, so this is butanoic acid. And then one reagent that will produce an acid chloride is SOCl2. This is thionyl chloride. And the structure, we have a sulfur bonded to 2 chlorines and double bonded to an oxygen. Sulfur is an element in the 3rd row, and so it has an expanded octet. It can hold more than 8 electrons in its valence shell. It can hold 10. And so it also has a lone pair. So this is thionyl chloride. This is also a liquid. And so if thionyl chloride is in the presence of a carboxylic acid, this will react to form the acid chloride, which is where the OH group from the carboxylic acid is replaced by a chlorine. Byproducts are hydrogen chloride and SO2, which is a gas, so that would be bubbled off. So thionyl chloride SOCl2, if you see that in the presence of a carboxylic acid, remember that that will form the acid chloride, where the OH group is replaced by the chlorine. There's one more reagent we'll talk about that can do the same thing. This would be phosphorus pentachloride. So we'll show a similar reaction, again with butanoic acid. Plus PCl5. PCl5 is phosphorus pentachloride. Phosphorus is another atom with an expanded octet, and in this molecule, phosphorus is bonded to 5 chlorine atoms. So each bond is a single bond to phosphorus. This is a new geometry we haven't discussed. But there are 2 chlorines opposite each other this way, and then we have 3 chlorines kind of in the x-axis, the horizontal axis. So here's PCl5, phosphorus pentachloride. This is another reagent that would produce an acid chloride if in the presence of a carboxylic acid. So same product here, another acid chloride. That's just the name of the functional group here, acid chloride. HCl is another byproduct, and then we have POCl3. So both thionyl chloride and PCl5 are called chlorinating agents. So these molecules, SOCl3 or Cl2, thionyl chloride, and PCl5, phosphorus pentachloride, are chlorinating agents. So they provide a chlorine to other molecules. So if the other molecule is a carboxylic acid, then the product will be an acid chloride. These reagents, thionyl chloride and phosphorus pentachloride, can chlorinate other molecules. They can provide a chlorine to other molecules. For our unit, we're focused on carboxylic acids, so we just need to remember that thionyl chloride and phosphorus pentachloride will produce an acid chloride molecule.